Alright, it's time to talk about phase changes. So, what do we mean by phase changes? In science, we refer to the state or the phase. Sometimes one, sometimes the other, but it doesn't really matter. Like a state of matter or a phase of matter. We're talking about solids, liquids, and gases. There is a fourth phase called plasma, but we're not really concerned with plasma in this course. You can study that on your own if you feel like it. But plasma is essentially the state of matter that you would find in the sun. Alright, so that's kind of not a whole lot of plasma readily available here on Earth. It also happens in lightning strikes. Anyways, so solid, liquid, and gas. We're talking about phase changes. So on this first little bit of the video, we want to talk about the different kinds of phases and how you can transition between them and what those things are called. So let's start. You know most of these already, I'm sure. Solid going to a liquid, we call that melting. Liquid going back to a solid, so this is when it's cooling off, we call that freezing, when a liquid turns into a solid. Now keep in mind, this does not only apply to water. You could talk about any liquid turning into a solid. You could have liquid nitrogen that freezes. I mean, that's a very low temperature, but that would also be freezing. All right, you could have a molten metal that solidifies, or lava that solidifies. Technically, when lava turns into rock, that's a freezing process. Okay? So then we've got liquid getting hotter. That would be boiling, or also evaporation, which we talked about the difference there, right? Boiling is when the liquid turns into a gas at its boiling point, and evaporation is when liquid turns into a gas not at its boiling point, okay? So in this video, we're actually not concerned with evaporation. We've talked about that already. So this video, we're talking about boiling or vaporization, okay? When gas turns back into a liquid, so it cools off, that's called condensation. All right, you know that when, say, like, water vapor condenses onto your glass of ice water, for example, and you get that sweat, that sometimes you call it sweat on the outside of the glass. It's actually condensation of water vapor. All right. Then you may not have known, a solid can turn directly into a gas without first becoming a liquid. This happens with what's called dry ice, or CO2, carbon dioxide. So you can turn straight into that. It's called sublimation or subliming. All right. And then a gas turning straight into a solid, that's called deposition. All right. Okay, so phase changes occur when an object is heated or cooled through one of those transition temperatures, which are called, if it's melting, the melting point. If it's freezing, the freezing point. Now notice the melting point and the freezing point are the same thing. It's just which way you're going. If you're going down in temperature, you call it the freezing point. If you're going up in temperature, you call it the melting point. Same thing with the boiling point, or basically we call that the boiling point. I guess you could call it the point of condensation, or the condensation point, but that's really uncommon that people refer to it that way. So the boiling point, all right, here we've got an ice cube and some ice cream, and they're melting. All right. So at the exact temperature of the phase change, so whatever temperature that is for solid H2O, or ice, that's pure, that temperature is 0 degrees Celsius, right? So at that exact temperature, the attractive forces of those water molecules to each other, the forces that hold them together as an ice cube, those have to be broken. Those attractive forces have to be broken in order to change phase to a liquid. Energy must be added to the thing in order to break the attractive forces and change this from a solid into a liquid. Important feature of this is that the temperature does not change while this occurs. All of the energy that you're adding to that ice is going to break up those attractive forces in there and turn it into a liquid. It does not change the temperature of the ice. The ice remains at 0 degrees the whole time that it's melting. Okay? All right. So if we were to continuously add heat to a particular substance, such as water ice, starting as a solid and ending as a gas. So let's just say right down here, we start heating this thing. It's ice that's less than 0 degrees already, so it just came out of the freezer. This is the graph we might see. All right, we've plotted temperature on the y-axis, and we have plotted energy added on the x-axis. And here's what happens. First, the solid heats up to 0 degrees if this is ice, if this is H2O. It heats up to its melting point, all right, and that's what we get there. Now, while it is melting, you'll notice the temperature does not change much, if at all. All right, it's very, very constant. In theory, it should remain exactly constant through that temperature phase until all of the ice has melted and it's turned into a liquid. Now, as we continue to heat, the liquid will now increase in temperature. So notice we've been adding energy this whole time, right? But the temperature's not increasing. Once it's all liquid, now the temperature increases again until we reach the boiling point, or the point of vaporization. All right. I just noticed a problem here with this diagram. That should say vaporization, not evaporization. Anyway, that's I didn't make this diagram, so I disclaim responsibility for that. But vaporization. All right. So that's vaporizing. It's becoming a gas at the boiling point. All right, so the liquid turns into a gas. Notice, this chunk of the diagram is way bigger than any other chunk. All right, it takes a lot of energy to break the bonds of the liquid molecules for each other and cause them to break up into gas, which is widely spread, right? So that takes a lot of energy, way more than freezing, way more even than heating the liquid up from its freezing point to its boiling point. So a lot of energy there. Now, if this is in a container that is sealed, the gas can then continue to increase in temperature after it all vaporizes. So, bam, that's steam, basically, that is now getting hotter than 100 degrees Celsius. All right, so this is what it would look like if you heat up some ice all the way through all of its phase changes until it's a gas and basically steam. All right. So this graph is called a phase change diagram, and it captures all of the relevant transitions of the material as it's heated. All right. So there you can have another look at it. These are all of the sections of phase change as you heat a substance, all the way from freezing, below its freezing point, all the way up past its boiling point. You get all of these different sections. First the solid, which is heating up to its melting point, then it melts through there, and then you're heating the liquid up to its boiling point, it boils through there, and then a gas. And it'll just keep heating up. You could heat this until you broke your container open if you wanted to. But there you go. So that's what's called a phase change diagram, and the really important thing I want you to notice is that the temperature does not change in these regions where the object is melting. The temperature stays constant at the melting point, and when it's boiling, the temperature stays constant at the boiling point until it's finished boiling, and then the gas is free to heat up past the boiling point. All right, so that's phase changes, and that's phase change diagrams. That's what I've got for you there. See you next time.